So we are back with a new video. So this is going to be today's question, which is 2981. Find longest special substring that occurs thrice, part 1 on LeetCode. So let's quickly jump onto the problem statement and see what this question is asking. So we have given, what do we have given? We have given a string which is consisting of lowercase English letters, and it is called special if we choose any strings inside the main string, like any substring, which are equal. So if you can see this part, so this triple D, like every character is same. So this is called special, and ABC is not, because they are different. Now, what do we have to do? We have to return the length of the longest special substring of S. Longest special means which is having the length, which is having the characters in the substring all equal. So we have to find out all those longest substrings which are special and occurs at least thrice. So if we found it, then return this, otherwise return -1. So this is regarding today's question. So let's jump on to the solution and the intuition part. So in the question, what we have given is basically a string. Let's say this is a string of containing character, let's say A, 4 times A, then 2 times B, then 3 times A, then 3 times B, and then 2 times A. So inside this string, we have to find out the desired result should be, so the longest and the special substring. So we have to return the size of the longest special substring. We have to return this. Okay, so how do we do that? So let's say for this case, the output should be like this, that we have A and 4 times A we have, and then we have 2 times B, then we have 3 times A, then we have 3 times B, then we have 2 times A. So if you can see here, we have 3 times A, then 3 times A again, then again we have 3 times A. So if we can see the 3 times A repeating 3 times, so that makes our condition, which is it is present at least thrice, and it is the longest among all the substrings, all the special substrings which we have. So we have to return this value. Okay, let's say if we consider any other value, let's say if we consider this 4 times A. So this 4 times A is not occurring anywhere. Okay, and what if we considered, there is one more option, if we considered 2 times A. So 2 times A is at the last, so 2 times A is in the last of this string. Here we have 2 times A, here again we have 2 times A, then here, and like we have a lot of 2 times A. So A would be somewhere around 1, then 2, then 3. So 3 in this one, because this 2 we have, then this 2 we have, then this 2 we have. Okay, so we have 3, and from here we have 4, and then 5. Okay, and from here we have 1. So that makes 5 and 6. These are 6. So this do satisfy the condition, but the length of the substring is 2, and here the length is 3. So we have to return the maximum one, which is 3. Okay, so this should be the desired output for this case. Now let's see how we are going to do it. So the first and the most easiest way is to apply the brute force, which in this question it should work, because this doesn't have any constant limit. I mean, the constant are very less. It is somewhere around like max till 50. So we can use brute force, and we can solve this problem within big of n square. That would be very easy to do. Basically, we don't have to do anything. We just have to, in brute case condition, we just have to like store all possible substrings of S, and then in that particular string we have to check one by one. Either we can create a hash map for storing, let's say in this case, let's say we are taking any smaller example. So let's say we have taken A, B, B, and then A. Okay, so in this case what would be our substring? Is basically substring array should be look something like this. So we have to create all the substring that is there in this string. So we start from A, then double A, then triple A, and then A. Wait. Yeah. So then triple A, and then we have A, B, then we have AB, then we have AAB. So similarly, like we have to consider all the substring. And inside this one we can either do a map, and what will this map do? Basically this map will store each and every strings. So let's say A and the count of these strings, like how many number of times this string is occurring, and then A, then the count of the string. Okay, so this we have to do for entire substring array, and in the end we can just traverse through this map, and then we can find if any value, if and the map should be of string and integer value, in which string is our substring which we get from here, and the integer is the count. Okay, so we are storing hash map. We are storing this in hash map, and we can check if map dot get value. If for any instance, if this value is greater than or equals to 3, then what we'll do, we'll basically store the maximum of size of that string. So here we are getting string, so we can just do one thing. We can just put an int and answer. This should be max of answer, comma map dot get key dot length. So this will give me the length of maximum string, and we'll store it in the answer, and we'll just return the answer. So this would be a easy approach to do. But if you see, if you're creating the substring, this will take big of n square times. So for this case it is fine, because like the constants are low. So the overall time complexity will be also somewhere around big O of n square. And if you want the solution, I can provide it in the description in this video. So yeah, and apart from this, let's say we have to optimize it. So what is the optimal solution? The optimal solution is to basically use sliding, sliding window technique. So this is going to be the optimal solution for solving it. And if we use this solution, we get the answer in big O of n times, because we have to iterate it in like only once in the array. So now how we are going to do for this solution? So basically in LeetCode we have two questions. So one is this one, which we have in today's question, and the another one is part 2 of the same question. So there the constants are high, so we have to optimize it. Now I'll show you how to do in the with the help of sliding window technique. So let's say we have given one string. Again, let's consider a 4 times a, then again 3 times b, then 2 times 3 times a, and then let's say b and then a. Okay, so here if you can see, we are getting the maximum possible value as we can get 3 from here. So we can get 2 3 times a. Okay. Then 3 times a means we are getting a, and we are getting this one, and we are getting this one. And here also we can get 1 times this 3 a's. So in total we are getting 3 times this 3A's. So this frequency is 3. Okay, now this frequency, since this frequency is matching like the condition which we have of at least thrice, so we have to return 3. I think that is the maximum possible size. So also we have another we have to include another cases as well, like in this B, if you can see. So in this 3B we have 2B, first this one, and then we have this 2B. So that makes 2 of 2 times B. So 2 of 2 B's. I'm writing like this, and here we have one more 2B. So the frequency would be 3, and which also matches the condition. So it will check, like right now the size is 2 in this case, and for A the size was 3 A's. Okay, so here the maximum, like the condition is passing, but the maximum of 2 and 3 is 3, so that's why we have to return 3. Now how we are going to do this with the help of this sliding window is basically, let's create a window. Okay, so this window would be let's create a 2D matrix basically. Yeah, let's create a 2D matrix which will store our window, and this matrix would be starting from A, B, and then ending to Z. So this will be going to be our 1 index. Okay, so this matrix would be of size, let's say I'm naming this as frequency. So this would be of 26 and 3. Why? I am just going to explain. So let us take here. So now for this case we have A and B. So I'm just representing A and B, and rest of the value we can let -1. So right now just have a quick look on here. Now we have 0, 1, 2. So why we have considered this 3? Because we want, what do we want? We want top 3 frequencies. And why is that so? Because if you see here, we have, let's say we are considering for A's. Okay, so let's say 4 times A. How many are like the frequency of 4 times A? So only 1, or let's start with the 1 only. So what is the frequency of 1 time A? Is basically A is here 1, 2, 3, 4, and then 5, 6, 7, 8, 9 times. Okay, now 2 A's. What is the frequency of this? So 2 let me clear this. Yeah, so first of all this 2, then this 2, then this 2A. That makes a total of 3. One is this, one is this, one is this. So 3 from here, and then 4, and then 5. So 1, 1, and then 1, 6. So 6 times we have 2 A's. Then 3 A's, what is the frequency? We have already seen 3. We have already checked, that is 3. And for other case like 4 A's, we have 1. But that is an invalid situation because it does not passing the condition. Okay. So now what do we have is 1A that is present in 9 times, 2A's that is present like 3 times, and 3A's that is present in 3 times. Okay, so now in this one, what is the maximum length of A? That is 3. Okay, so for A we have to return this. So that's why every time we have to just take only the top 3. If like it doesn't matter, even we have any more A's present, like any more number of times, say like 5A, 6A, any number of times present. So what do we have to do? We have to maintain only top frequencies in our array, and I'll show you why. Later on. Okay, so let us see. We have created this 2D matrix, and then what we have to take? We have to take one variable that would be our last scene, and this is of character type basically. So let me put star over here, because it is checking basically for if the current if the current index if the current character is the same as previous one or not. Okay, so we'll start from here. Okay, and some more things we have to include. We have to include this window length. So this window length, I'm just setting it as 0, and we have to also set max length, which will be our answer, and right now I'm considering it -1. Okay, now what do we have to do? Let's see. So first of all, fill the array with -1. Okay, now what we are going to do, we are iterating through the string. Let me write down the string here for more clear perspective. A, then 2 times B, I think 3 times B, and then 3 times A, and then 2 times B, and then 2 times A. Okay, so let's say this is the string. Okay, so let us consider for this string. So now what do we have? We have last seen as star, and then we have window length as 0 and maximum length as -1. So now what we are going to do, we are we have to start from this first index, which is A, and then we have to check. We have to check if this first window is equals to last seen or not. So if this is not equals to the last seen, so that means we have to update the last seen value, and then we have to update the window length value. And what if this is equal? So if let's say for next element, let's do for this one first. So we'll update the value 1 here, and we'll update the value 1 as here. And then if we and then moving on to the next element, we'll see if this is equals to the last seen element or not. So right now this is, so we will just increase the window length to 2, and we'll do it as the same as here. Now we'll have to do these within the complete string. Now if we go to this third index, we'll like the value of the last seen is same, so we're just going to update this one, and we'll just update the value as 3. Now for the next index, this value is again A, and this value will be changed as 4. Now this 1 2 3 is already filled. Now what do we want? We want minimum of these 3 frequencies. We want minimum of these 3 frequencies, and in the minimum we will check. So right now the minimum is 1, so minimum frequency is 1 right now, and window length is 4 right now. So we'll check if window length is greater than this minimum frequency, we'll update the minimum frequency as 4. So right now it will be 4. See, we want top 3 frequencies only, and from the top 3 frequencies only we are getting our answers. So that's why we have to update it every time. Now we'll get to this B, and the last seen value would be different. This is B. Let me erase this, and so it will change to 1 because I'll already tell you the condition. I've noted down here as well. So if the current character is equals to last seen, then we'll do just window length plus, and else we'll do window length as 1. So right now because this is different, so we'll make this window length as 1, and we'll update the value here. Now again the next character is the same with the last character, so we'll update 2, and we'll update here. Next character is sorry, this would be 2, and next character would be 3, so we'll update it with 3. Now this is A, and the value is getting changed to A now here we do 1, and then we see minimum of this 4 to 3 is now 2. Okay, and window length is 1. So since the window length is not greater than minimum frequency, we'll let it be. Okay, now we'll move to next element. Next element is A, and the window length would be 2. Now the window length and minimum frequency again is same, so we'll not do anything. We'll do only if the window length is greater than the minimum frequency. In the next case, we have window frequency is 3. So in this case we can edit it because this 3 is greater than 2, so we'll just edit this 2 to 3. Then now we'll move to next B. So this B again we'll have this B, and again we'll have this 1, and we'll update. Okay, so minimum of 1 to 3 is 1. Minimum is 1, and window length is 1, so we don't have to make any changes. Now B, so that makes 2 again, and minimum of this 1 to 3 is now 2. Is 1, but window length is 2, so we'll update 1 with 2, and then the next character would be A, so we'll just cut it down to A, and we'll just do this to 1. So the minimum frequency now here is 3 and window length is 1, so we'll not update anything in the array. And the next one as well, we have the window length is 2, but the minimum frequency is 3, so we'll not do anything. So this will be our final array, and similarly we have to maintain from A to B till Z. Okay, so we'll have to maintain for every like 26 characters. So yeah, this is all. And now our final array would be, let me clean this. Yeah, so this would be 4 3 3, and this would be 2 2 3, I think 2 2 3. Now what we are going to do with this final array, we are basically checking the maximum length. So maximum length, how we can find is basically, let's suppose this 433 is there. So 433 means we have 4 times A, we have 3 times A, then we have 3 times A. Then common, if we talk about common we have 3 times A. So we will have to take like in the topmost 3 frequency, we'll have to take the minimum of the frequencies. So that would be 3 now. So this minimum frequency would be 3 here, and from this minimum would be 2, and similarly we have to do it till Z. So for Z right now minimum would be -1, and we'll have to take the maximum of all these rows. So that maximum would make 3, and 3 would be our answer. So this we have to do, and I'll show you in the code what we are doing. But this is the basic intuition for this, and we have to implement it in similar way. So let me just jump back to the code. Yeah, so here is the code for this. So we have this maximum length function given. What we are doing, we are creating one top 3 frequency array of 2D matrix. First of all, we have taken 26 because we have 26 alphabets, and then we will consider 3 because I've already told you we are taking top 3 frequencies. Then we are filling this array with -1. Then we are taking 2 variables. First of all, last seen, which is of type char, and which will assign to star because star is not present in the string list. And next is window length. So right now we have assigned it to 0. Now we'll iterate through this string, and we will find the index first. So finding the index, we'll just subtract it with -a. So that basically does ASCII value subtraction, and that will give me the index of current value. And yeah. So if after finding this index, what we'll do, we'll just see the window length. And so this is the condition which I was talking about. If the current character is equals to last seen, then we'll just increase the window length. Otherwise, we'll put it as 1. And also last seen will change to current character. So this is regarding this. And the next part would be to calculating the minimum index. Why we have to calculate, I've already told you in the notes. So we are just iterating from 1 to 3, and we are checking what is the minimum index amongst the top 3 frequencies, and we are checking if the window length is greater than our top 3 frequencies, then we'll update the minimum index of top 3 frequencies with window length. Otherwise we'll just let it be. And here what we are doing, here we are finding the maximum length of substrings. So we are just taken a variable max length is equals to -1. We are iterating from 1 to 26, and because we have 26 rows. So for every row we have to find, first of all we have to find the minimum of columns in every row, and then we have to do a maximum of that, and we'll have to store it in maxlen. So this maxlen will give our maximum number of longest special substring that we'll have. Yeah, so this is regarding the code. And if you talk about the complexity of this code, this would be somewhere around big O of n, which is a lot better than big O of n square. So this is the optimized version of this code, and this you can use in 2982 problem as well. So yeah, that's all for this video. I hope you understand this, and please make sure to like and subscribe. Thank you. Have a nice day. Bye bye.